Okay, we're looking at compound inequalities under the section of linear inequalities in intermediate algebra. And of course you go to my website and find exercises. Just go to intermediate algebra and then look for compound inequalities. Alright, moving right along. So we have this inequality here, I should say compound inequality because of the OR. So we want to go through and find the solution for the first one and then the second one, and then we're going to draw out a graph and take a look at what we got. So in this particular one here, I'm going to go ahead and subtract 3 from both sides. So negative 3 plus 3 is going to be 0, so we're going to be left with negative 3x is less than negative 2. Multiplying both sides by the reciprocal of this negative 3 here because we want to get a 1 there. And I think what I'm going to do here is just kind of try to save some room. Ooh. Okay, that's negative 1/3. That's terrible, but we'll write it over here a little better. So we end up with x. Now because we're multiplying through by a negative, we got to remember to flip this inequality. So this becomes a greater than sign, and negative times a negative is positive. So we got x is greater than 2/3. Now let's go over here and work on this one. So let's subtract 2 from both sides. So we end up with 5x plus 2 minus 2 is greater than or equal to 2 minus 2. So this is going to end up reducing down to 5x is greater than or equal to 0. And when we multiply through by 1/5 to both sides, which I guess I'll just do right here, we end up with x is greater than or equal to 0. Now remember we have an OR sign, or we have an OR. I don't know about the sign, but we've got an OR here. Okay, so we got x is greater than 2/3, or x can be greater than or equal to 0. So just by drawing a number line out, I'm going to label 0 here, and remember it's includes 0, so we're going to fill it in there, and it's everything greater than 0. And then of course we have a 2/3 here, and it doesn't include the 2/3. Okay, so how does this work? Alright, if I pick a number, it's got to satisfy both this one or this one. So it can satisfy both of them or just one of them. So in other words, I can pick a number anything greater than or equal to 0, and it will be true for this, well, I should say for this one, anything greater than or equal to 0, but it doesn't have to be satisfy this. So in other words, I could pick a 1 in here, and this would become true. But this is not true, but it doesn't matter because it's an OR. It's not an AND, it's an OR. It doesn't make any difference as long as it satisfies one of them. If I were to write this out in interval notation, we would say this right here. Okay, it includes 0 and goes to infinity. Now let me write one up for you. So this is what you got. 6x is less than or 4, or 4x minus 3 is greater than or equal to 7. And I've drawn you a graph. This includes 2/3 and this includes 5/2. So remember it's OR. You can pick something over here, or you could pick something over here. It doesn't matter. Okay. But if this were an AND sign, if this were AND right here, okay, then this would be no solution. Alright, so I'll let you go ahead and work this out and see if you can come up with what I've got here displayed in this graph.